Today we're going to look at correlation and regression analysis. The main topics for today are the type of relationships, direction of the relationship, and the strength of the relationship. We're going to look at two variables. The independent variable can be controlled or manipulated. In our case, the independent variable is also known as the explanatory variable, and we're going to denote that with the letter X. The dependent variable cannot be controlled or manipulated. We're going to denote that with the letter Y, and that is also known as the response variable. Let's look at an example. A manager may wish to determine whether the number of years that a salesperson has been with the company has anything to do with the amount of sales that they make. Notice here that the number of years is going to represent our explanatory variable. We cannot control that. So X, in this case, is going to be the number of years that this person is going to work with the company. The amount of sales is the outcome of the person's sales. So our Y variable in this case is going to be the amount of sales. So in this case, we're trying to figure out if experience matters or not. Does more years at the company contribute to more sales, or is there no relationship? Example 2. I am interested in determining if there is a relationship between the number of hours studied and test scores on an exam. I take a random sample of 6 students and find the following. Here, if you look at the number of hours studied, that's something a student controls. So this is going to be our explanatory variable, or our X variable. And the grade is something that a student cannot control. That's going to be the response variable. And that's also the Y variable. So in this case, the student can control how many hours they study, and the response variable is the outcome of the test. Now, if you look at the results, the person that studied 6 hours received a grade of 82, and for those individuals that study very few hours, 1 hour or so, have a poor score. So there seems to be a relationship. It seems to be the more that you study, the higher your grade will be. So this is a positive relationship. There's a positive relationship because the longer we study, the higher our grade. To help investigate the relationship between the two variables, we usually start by plotting the variables on a graph called a scatter plot. So let's graph the previous data on a scatter plot, and we'll see what the shape of the graph looks like. I'm going to enter the data on StatCrunch, and we'll look at the scatter plot. So go to Graph, Scatter Plot, and our X variable is the hours, and our Y variable is the grade. Press Compute, and we do see there is a relationship between the hours studied and the grade. The more that we study, the higher our grade. So there is a positive relationship. There are 3 types of relationships: linear, non-linear, and no relationship at all, or the random scatter plot. Here's some graphs that demonstrate the different types of relationships. The first one is a linear relationship, and it looks like there's a positive relationship. As you go to the right, it increases to the right. In the second case, there appears to be a negative trend or a negative relationship. As you go to the right, the graph falls. In the third case, there doesn't appear to be any pattern at all. This has no relation. In our class, we will only discuss the 2 types of relation that are linear. We will only discuss positive relationships or negative relationships. We will not do any other types of relationships in our class. A positive relationship exists when both variables increase or decrease at the same time. A negative relationship exists when one variable increases and the other decreases at the same time. Now let's try an example where we compare a positive versus a negative relationship. So I have 6 examples here, and I want you to pause the video and try to figure out if these are positive relationships or are they negative relationships. So on each of these, just tell me negative relationship or positive relationship. Don't forget to pause the video and try it on your own before I give you the answers. Number 1, age past 60 years and strength. This is going to be a negative relationship as the number of years increases after 60, we are going to lose our strength, so there's a negative relationship. As we get older past 60, we're going to get weaker, so this is a negative relationship. Number 2, height and weight. This is a positive relationship. As we look at taller people, they tend to weigh more than others. Someone who's 6 feet tall is going to be, in general, heavier than someone that's only 5 feet tall. So this is a positive relationship. As the height increases, the weight of a person also increases. Number 3, days absent and final grade. In this case, we have a negative relationship. The more days you are absent, the lower your final grade in general. Number 4, income and education level. Now this one's kind of tricky. We have to think of the income as the explanatory variable. So this is something we can change, and then we look at the education level. So this is a positive relationship. If we look at lower income people, they might not be able to afford a higher education. So we're going to have a decrease in education level. So as the income increases, the education level also increases. The lower the income, the lower the education. So this is a positive relationship. Number 5, age and blood pressure. As we get older, our blood pressure tends to increase. So this is a positive relationship. The younger we are, the lower our blood pressure is in general. Number 6, road widths and car accidents. The wider the road, the less car accidents we get. The smaller the road or narrower the road, the more car accidents we get. So this is a negative relationship. As the width increases, our car accidents decrease. So there's a negative relationship. Pearson's correlation coefficient. The sample correlation coefficient is denoted with the letter R, while the population correlation coefficient is denoted with the rho symbol here. The range of the correlation coefficient can go as low as -1 and up to +1. A strong positive linear relationship would indicate an R value that's close to +1, while a strong negative linear relationship would imply an R value that is close to -1. If a linear relationship does not exist, then R is close to 0. Here are some examples of the correlation coefficient. The first one, the R value is 0.7. It's very close to 1, so it's pretty much linear. Here the R value is 0.3. It's very, very close to 0, so you can see that the dots are all scattered everywhere. There's not really a strong relationship. When R is equal to 0, it's random and completely, and there's no relationship at all. If R is equivalent to 0.7, you can see that there's a strong negative relationship. It is very linear. If r was equal to -1, you would have a perfectly straight line where the dots are on top of the line. Here we have r equal to -0.3, so it's pretty much scattered, but there's still a trend downwards. And again, if r is equal to 0, there's no relationship at all. To calculate the correlation coefficient r, we have the following formula. R is equal to this expression here. And since we're going to do all of our problems on StatCrunch, we do not need to use this formula for a class unless you want to practice the work by hand. For the homework, when you click View an Example, they will do the problem by hand, but please don't do it by hand. Just use StatCrunch for your problems. So now the question is, how do we know if our correlation coefficient is good enough to be considered linear or not? Well, that depends on your correlation coefficient and the sample size. So we'll need to look at the correlation coefficient, and we'll also need to know the sample size. And from there we can use a table to figure out if it's linear or not. And I'll show you that now. For example, in this question, we have a table that's given of critical values. And on the left side here of the table, you're given the sample size. So if my sample size is 3 and my correlation coefficient is greater than 0.997, then it will be considered linear. If it is less than 0.997, then it is not linear. Recall from algebra, we have the equation for a line is y equals mx plus b. In statistics, we have the following equation for the regression line. The regression line is also known as the best fit line. And here is the regression line. It is given by y hat equals b sub 1x plus b naught. Now the b1 here is going to represent our slope, and our b naught is going to represent our y-intercept. Here is the actual formulas to calculate b naught and b1. Remember, b naught is our y-intercept and b1 is our slope. An engineer wanted to determine how the weight of a car affects gas mileage. The following data represents the weights of various domestic cars and their miles per gallon in the city for the 2008 model year. Draw a scatter plot and determine the type and direction of the relationship between weight and miles per gallon. So in this case, we have the weight is going to be our x variable and our miles per gallon is going to be our y variable. We also want to find the sample correlation coefficient R, find the regression equation, and use the regression equation to predict a car's miles per gallon if the car's weight is 3,500 pounds. So we have to answer these 4 questions. So here is our data for the domestic cars. Their weight is given here. And remember, their weight is our x variable and the miles per gallon is going to be our y variable. So please type in the weight on one column on StatCrunch and the miles per gallon in another column. Let's try the problem now on StatCrunch. I have entered the weight for the cars in one column and the miles per gallon in another column. To look at the scatter plot, go to Graph and click Scatter Plot. Select the x variable as the weight of the car, and our y variable is our miles per gallon. And then we press Compute, and here is our scatter plot. We can observe as the weight of the car increases, the mile per gallon decreases. So there's a negative relationship because as the weight increases, the miles per gallon decreases. To find a regression equation, we'll go to Stats, Regression, and then click Simple Linear since we're looking at a line. I want to select the x variable as the weight and the y variable as the miles per gallon. Click Compute, and you'll see that our correlation coefficient is given here as negative 0.964. So there's a strong negative relationship because this number is very close to -1. Also, we have the regression equation here. The miles per gallon is equal to 44.879 minus 0.007 times the weight. So this is our regression equation. If I want to do a prediction for a certain weight of car, I will have to go to Stat, Regression, Simple Linear, and again we're going to select the x variable as the weight, the y variable as our miles per gallon, and I'm going to scroll down to the bottom and click here the prediction of y. Since I want to predict for a car that weighs 3,500, I'm going to enter 3,500. This is an optional feature if we want to predict a certain value of y given a input of x. And we can also change the level of confidence if we like, but we're going to leave it as 0.95. We'll press compute, and here is our prediction. As you go to the bottom, you'll see the predicted y value is given here as 20.25. So for a car that weighs 3,500 pounds, we're predicting about 20 miles per gallon. From StatCrunch, we have the miles per gallon is equal to 44.879 minus 0.007 times the weight. Now the weird thing about StatCrunch is they write their regression equation kind of backwards. It should be miles per gallon is equal to negative 0.007 times the weight plus 44.879. We want the slope first, the x variable, then the y-intercept here. So it's kind of backwards, so just be aware that the regression equation will be written in a different order. Sometimes the homework wants you to write it in this form: y hat equals negative 0.007 x plus 44.879. So this is also another acceptable form for the regression equation. We have that our correlation coefficient, R, is equal to negative 0.964, and that indicates a strong negative relationship. If we plug in 3,500 into the equation for the weight, we can calculate the predicted miles per gallon, or we could go and use StatCrunch to predict a car that weighs 3,500 pounds.